This conference will now be recorded.
Video.
Sir, if you switch on video, the bandwidth is going to be lower and lower, sir. So it is very difficult for the participants. Even we are staying at different places, the net speed is too low, sir.
You are using mobile?
Yes, sir.
Or you are using desktop?
Majority people are using
mobile only. Right. Okay. Now my question is now, because you see here, learning blockchain theoretically doesn't provide you the interesting concepts of blockchain technology. You should have some hands-on approach on these things. So I recommend, if you are having laptops with Ubuntu, it is recommendable to do some hands-on approach so that you will get benefited of these concepts. Those who are having mobiles, later you can practice it, but I recommend at least tomorrow, if you are going to have some laptop and good bandwidth, so that it will be a good thing. You can get benefited of this FDP. So we are conducting FDPs, I mean, Atal or the NIT, we are not conducting for the namesake, right? Where the student, where the faculty community should get benefited of this, and whereas and then the students should get benefited of this based upon these FDPs. Anyway, in the morning session, I think the other resource person, we concentrated on the introduction part of the blockchain technology. Now let me see. I'm going to emphasize on the, if you have seen, the blockchain technology is the future of digital trust. All right, we can create a distributed trust. How we can create the distributed trust, that's important. Now, a few questions I'm going to pose to the participants to have an active in the active participants actively involved in the FDP. What is this blockchain is all about? You can post your you can post your, what do you mean by blockchain technology, or what do you mean by blockchain? Right, members of the distributed ledger.
Hello.
Yes.
Hello. Actually,
yes.
blockchain is the distributed, decentralized public ledger technology, where we have to keep our we have to keep our data in a block, and it will goes through the goes through the hash value, and the data is not tampered proof, or its immutability, confidentiality, integrity has to be maintained.
Yes, right. Now we'll try to see what are the words you're giving it. So someone is telling distributed ledger, someone is telling about immutable, someone is having the concept decentralized. Now there are so many concepts which is involved in blockchain technology. It's not a single topic which we need to, we are going to have it. It's a multidisciplinary concepts which we are including in the computer science. Right. Now my session is we will go like this. So just we'll try to see here. Right, I'll concentrate on some of the important concepts which we are going to see here. Now, the blockchain will play important. Quickly try to see some of the role. We'll try to see. First, we'll try to see some of the distributed concepts which we are interested in. As you already know that we are already enjoying the 4G technology. Very soon, we are going to see one of the distributed networks. One of the distributed environment is 5G. 5G is a distributed environment which we are going to have it, right? So it's one of the interesting wireless communication where it will play a very important role. And whatever the technology which is going to come, the success of these technologies purely depends upon the security. So cybersecurity is the biggest concern which we are going to have it, that need to be addressed by the developers, or by the industries, or by the research organizations, to provide this, not only the research side, but also every stakeholder should be aware of these cybersecurity issues. So this is a very important part that need to be concentrated. And the very important one, people were talking about the huge volume of data which is getting generated. Now, all the very important aspect which we are going to which we are going to discuss is big data, right? Which is very important. The biggest concern with big data is not only to analyze the data, but what about the privacy, right? Who has given the permission to analyze the data? Whether whatever the data sets you are taking, whether it is appropriate, they have given the permission, or you are taking the permission to analyze the data, right? For making effective decision making. That's the biggest concern. Privacy is the biggest concern while analyzing the data. That's even one of the important aspects which we are going to talk about, right? And now we are going to have one of the important applications is which we are going to talk about digital currencies. We are not interested with the digital currency or financial sector, but we are interested in the underlying technology of the digital currency or Bitcoin, which we're going to talk about, which we are going to talk in today's class is blockchain, right? Blockchain technology makes use of the very effective of digital currency, which we are going to see in detail about this. And the other one is the ad hoc network, which we call them as a vehicular ad hoc network or assistant transportation system, vehicle-to-vehicle communication. IoT will play an important role here. Even we can establish a blockchain network among the IoTs, where we need to ensure a trusted mechanism among the assistant transportation system. This is another area where manufacturing sector or automobile sector, they're concentrating on this the concept. All right, and this is another one where there is a huge demand is there on the industrial IoT, which a lot of research work is going on. The industries are putting a lot of effort for implementing this industrial IoT. Now, if you see, the 5G is distributed in nature. Big data, it is coming from various heterogeneity. The digital currency is also distributed, and transportation system is also distributed in nature. We can go for the distributed because the vehicles will be distributed, and industrial IoT is also distributed. So therefore, the era which we are going to discuss here is all about distributed thing that we are going to concentrate on. Right. Let us see about the intelligent thing which we're going to talk about. The IoT is a part of intelligent thing. This is another which we're going to have it. Edge computing, which was introduced by Cisco a few years back, 2013. They started working on fog computing and edge computing, and they're putting a lot of effort on these edge computing concepts, which you can have it. And we are enjoying the facilities of cloud computing or cloudification. We need to have it, but that now next cloud computing is all about distributed. May I ask a question whether cloud is a distributed or centralized? Can you answer? Whether cloud computing is it is centralized.
Centralized. Yes, sir.
Yeah, very good, very good. It is a centralized, but internally it is a distributed or decentralized. But at one place, all the data centers will be there. It is centralized in nature. And what is a major centralized cloud computing is a single point of failure. Single point of failure with a failure, and it can be easily hacked. That's a major problem with with the cyber attacks, which is going to happen on the cloud computing. So even cybersecurity for cloud computing will play an important role there. So need to be ensured with the cloud computing concept, which we have. All right, and people will talk about the technology which we are going to the next concept, which is a very important one, is the artificial intelligence, machine learning, and the deep learning. And people are talking about not only about the analyzing and learning the concepts, but also machine learning security is also playing a very important role, which we will have it. Okay. As I already told you, the fog computing, which we are going to have. So these are some of the latest. We are having almost 30 different technologies, but I have mentioned very few where the blockchain technology can play an important role, and we can solve the problem with respect to these concepts. Okay. So when you see the next, maybe in 2020, we are going to see very good hype. If you have seen yesterday, there is a distributed ID, which was proposed by the banking sector, right? They have proposed a distributed ID, and they have started using in the Ireland as well as in UK. They have used the distributed ID for the banking sector using blockchain technology. All right. So we need to go for the next decade technology, which we are going to call them as Industry 4.0. the industry 4.0, which we're going to have it. This is now even blockchain technology, which comes under the industry 4.0, where it will play an important role. Okay. Now, just quickly, let us see some of the landmark technological advances which we have started our computer era, which started from 1940s to up to now. What are the different landmark technological advances we come across? Right now, let us start with this digital computer, which is a very early age. We have already seen the fruits of digital computer, which we are effectively utilizing. Then after that, then we are going to use networking, right? This is a very important one. Internet is played a huge impact in our daily life, and it has become the part and parcel in our daily life. So therefore, the network is playing an important role. Then once the internet is introduced, once the network concept is introduced, then people will start using the applications. So therefore, they started using Usenet, email, messaging, chat boxes. They use effective communication. All right, sitting at your places, and we can effectively communicate it. The communication was started once the network has been evolved, right? And then the next, we are using this facility from last 6 to 7 years. We started using the web, right, for information sharing, for resources sharing, e-commerce, as well as entrepreneurs. We are using the web development and the web World Wide Web concepts very effectively for effective utilization of the resources. Right, this is another technological advances which we have come across now. Right, the mobiles. Yes, we are in a current era. We are in current generation. We are using a lot of apps. We are a lot of using mapping snaps. We are using for solving the day-to-day problems. We are using a lot of mobile apps which we are going to have it. Can I know what is the next thing after mobile? The participants can guess what is the next thing we can get it. After mobile, what is
cloud.
The next one? Next technological advances? Cloud. Yes, cloud. Yeah, maybe next. Any other?
Cloud.
You can type
Neural networks.
only cloud. Cloud is another.
IoT,
Blockchain.
IoT,
Machine learning.
Internet of
IoT for computing. Yes, good.
Quantum
Internet of
computing.
things, right? All our latest technologies which we are going to have. Right?
Quantum computing.
No, I'm talking about real time, because we are not talking about research oriented. Yeah, we are not using. We are using quantum computing in reality applications. Not critically. We are not. Because we are using, the usage is different. Concept is different. Now, see, for example, that's why blockchain is not, though it is a concept, we need to apply in reality for solving the day-to-day problems. You take IoT, yes, it's a concept, it's a technology integrator. We need to apply the concepts, as well as we need to apply somewhere for solving the problem. See, right after mobiles, people were using mobiles with social network. Right, social media networking, social networking is playing a lot of important concept which we're going to have. Right, then after this social network, then we are talking about the analytics, how to analyze the data, machine learning, Internet of Things. Because now there is a lot of emphasis. Now data is the value now. Data is the money now. Nowadays, so because a lot of emphasis, a lot of importance will be given for the data, which is a very important part which we are going to have. So data. That's why people are talking about analytics. People are talking about learning the algorithms, deep learning mechanisms, all right, and then Internet of Things, which is a very important. Can I get one more, which is very important, the final one after this? Computer era, yes, computer vision from last 10 years, we are enjoying a lot of image processing, a lot of video processing, a lot of signal processing which we are using in computer. IoT is already discussed now. What is the next technological advances which we are going to see? Cyber security. Yes, cyber security is not a new one. It is from last 40 years, cyber security is required, but a lot of emphasis which we are going to have.
Visualization.
Augmented decision making. Pardon?
Visualization.
Visualization. Yes, it's there. From last 10 years, visualization is the biggest concept which we are going to have. Right.
Sir, quantum computing.
virtualization.
Yes. Yeah.
Virtualization.
Now, if you see this one, You got this one now?
Oh,
So we were
Virtualization.
talking about, yes, virtualization, but the next era which we are going to talk about everything now. See, now I started this FDP. Being a coordinator, I'll start with a smart contract. See, for example, I can view 121 members, but when I ask a question, only 5 to 10 members or 15 members will respond. Remaining people are not responding. They are the passive listeners. If I take this one, the smart contract will be executed immediately, and then immediately I'm going to identify who are not listening and who are listening. The smart contract need to be executed for online learning now, because the future is in this epidemic, in this crisis period. We need to have a smart contract. Now, what is a smart contract? I'm going to execute it here. Now, whoever attended this FDP, everyone should answer. Otherwise, I'm going to mute them. I'm going to disable them. That's a smart contract I'm going to execute. So the future is all about what smart contract concept, which we're going to talk about here is how to establish the smart contract is a very important. Now, see, we need to concentrate on the smart contract concept. Now, we need to concentrate on the blockchain. We are not interested. We are not interested with Bitcoin, but because the underlying technology of Bitcoin is the blockchain technology, which we're going to have it. Okay. So, and then next is the future is because we are talking about internet of money, isn't it? Now, if you are having internet, we have a data, then your internet will make you to earn the money, right? Internet of value, isn't it? Internet of value which you're going to have it. So, therefore, we are going to talk about the very interesting one called blockchain technology with respect to this interesting parameter which we're going to discuss about that, right? Which is a very important part which we're going to have. Okay. Now, if you see this wave of information technology which has happened from 1960s, along with the evolution of digital computers, they started with mainframes. They started with in 80s. They have gone for mini computers. In late 70s, they've gone for personal computers, and then we are in this era. We are in this era, networking and network and distributed computing era. A lot of companies they put in a lot of potential towards the networking and distributed computing. The next information technology which we are going to have it. It's not clear. Audio and video is not clear. 070.
It is clear. Clear, sir.
Yeah. Because I've seen that your voice is not clear. It's okay now. So, right
Yes.
now, if you have seen,
Okay, sir.
if you have seen here, if you have seen here, now see the next decade technology which we're going to have it is IoT, cloud computing, and big data, which is a very potential areas where the industry is looking over that, and a lot of research work need to be done on these areas. Right now, we can apply the machine learning, and we can apply the cloud computing. We can apply the big data. Now, the question comes to you: how to make trusts? Because how to make the companies they will create an IoT environment. The companies that are doing the cloud computing, the companies are doing a lot of big data analytics. How it can create a faith, or how it can bring the faith, build the faith among the people. That's a big question. Means a trust is ensured, a trust is required. A trust is required. So therefore, a biggest concern for the developers or technical people, how to establish a distributed trust here. That's a big question. So the biggest challenge which we are going to talk about is how to establish a trust which we are going to have it here. A digital trust need to be ensured. Now, whether this trust is there now, a question to you, whether digital trust is there. Now, human trust is there.
No, sir.
Trust is not
No.
there. Okay. Can I know why? No. So I'll give a small example. Now people are saying that suppose now if I'm not trusting my participants that right they are not listening, then I cannot teach it. Now initial trust is what? Yes, all my participants who joined definitely they will listen my lecture. Then because I can't waste my time by sitting here if you're not if I'm not trusting you. And if you are not trusting me, you cannot sit there and listen my lecture. Because see, there should be some initial trust between the you and me. Right? Later, that trust can be misused. You trusted me, I bluffed you. So that why cybersecurity attacks were happening because of the lack of because of the trust only. Now, yes, definitely the digital trust is there, but these trusts are based upon certain policies, certain principles, right? Certain regulations need to be deployed, right? For example, I'll give it. Now, father is going to trust the mother, mother is going to trust the father, wife is going to trust the husband, husband is going to trust the wife, right? Mother is going to trust the kids, kids are going to trust the mother, right? All the initial trust, because we are human beings, we are trusting each other. Right, the same trust we can deploy in digitally. Right, it's a big challenge. Why cybersecurity attacks were happening? Why network attacks were happening? Why information data attacks were happening? Because we are trusting each other. The devices are trusting each other. Therefore, attacks were happening. The next era which we are going to talk about is how to establish a distributed trust. That's a very important point that we need to be concentrated. Okay. So now I'm talking about the blockchain technology with respect to digital trust, right? How to establish a digital trust among the entities to ensure the transparency. That's a very important, to ensure the transparency. So therefore, we are talking about the next decade technology for ensuring digital trust. One of the possible solution where we can get is blockchain technology. Right, this is a blockchain technology where we can establish the digital trust. Okay, so we are going to talk about the blockchain technology with respect to a digital trust. If you see right now, the digital trust which we are going to establish, a digital trust which is sitting in the middle and which is going to monitor the whole universe. That's the biggest problem. And now, if this person is a single point of failure is going to happen, and definitely the trust cannot be established among the whole universe. That's why it's a centralized system which is happening now. Okay.
That centralized systems we called as a pen testing.
Yes.
Centralized systems we called as a pen testing, sir.
I'm not hearing you. Please come once again.
Sir, actually, you said no, the centralized devices, no?
Yes.
So that centralized devices we called as a pen testing.
So I'm not talking about penetration testing. What are the mechanism we are going to have a centralized system? It is a trusted system. You can apply whatever you want, but there are certain problems are there with the distributed trust.
It's a tower. It's a tower.
There are some problems are there with the centralized mechanism that I'm going to discuss next. Okay. See, if you have seen the next decade of technologies which is happening now here, if you have seen all these things, right? Now, if you are going to have the internet has the biggest advantage because of the internet only. People were talking about this internet concept, right? Which is going to happen here. This is the internet is almost right 86%. We are depending 86% of that in the internet, and the next one is a very important one which we're going to which we need to concentrate is, if you see this one which we're going to have it here, blockchain. But because the industry is taking this as a challenge and they're solving a lot of problems which they are having, is a blockchain. The industry, 68% of the companies already started working on blockchain technology for providing the solutions for that. Right. Then after that, you can see here, you can see how artificial intelligence is putting a lot of evolution with these things. But we need to concentrate on the blockchain technology, how it is going to provide the solutions for that. Okay. Right. Now, let us quickly try to see about how this traditional online transactions happening. Because I'll try to cover some Bitcoin concepts. I'll try to see how the why Bitcoin is playing an important role for performing online transactions, for providing that. Just I'll try to see what is the problem with the traditional online transactions which we're going to have it. Now, how the transaction is happening, right? How the online transaction is happening. Right now, if you say if the two persons are there, they want to transact their amount. User A and user B want to transact their amount. Right now, user A is sending 10,000 rupees to the user B. We call them as a transaction. right? You already studied in DBMS what do you mean by this transaction. Now, if you see this transaction, which we're going to have it, what is that? These transactions will be monitored and will be validated and it will be verified by the trusted third party. Now, we are using a word called trusted third party. Now, these two persons need to be trusted by the third party because need to be validated by the third party, right? A banking sector can be a trusted third party, right? Now, we are going to have two persons, we can call them as a trusted third party, which we're going to have. Okay, and what this fellow duty is, trusted third party duty is to validate the entries, is to safeguard the entries which is happening, is to preserve the historic records. How the banking is working is to validate these entries because whole day, so a lot of transactions going to happen. The trusted third party duty is to what? To validate the entries, to safeguard the entries, and to preserve the historic records. That's why. Therefore, for that, what we are doing, the banking sector is paying a lot of amount to these people. They are very expensive. Trusted parties are very expensive and very slow because every entry to be validated, every entry to be safeguarded, every record to be preserved, right? All these things need to be ensured. So therefore, what we are going to do, they are very expensive, they are very slow because we are trusting the other person. Definitely there is a subject of fraud. There's a problem. This is a problem with the trusted third party, which we are still facing. These are the problems which we're going to have. Okay. Any doubts here? Any doubts?
Hello, sir. Hello, sir.
Hello.
Hello, sir.
No doubts.
Hello, sir.
Yes.
How party can identify fraud?
Hello.
Hello, sir.
Yes.
Anyway, we are believing third party now.
Yeah. Currently, we are believing that's a third party.
How third party can identify the fraud, sir?
How the third party
Can identify the fraud?
see? Of course, whatever the validated now, if, for example, in DBMS, if we have studied the information, whatever the transaction is happening, we need to maintain a log.
Okay.
Isn't it?
Ah.
What is the purpose of log? The
that
log
lie-
information, whatever it is happening.
Yeah.
Suppose, for example, I'll give a small example. Now we are
We
going
can
to
revisit.
start.
So we can revisit it. We can revisit what has happened. We can recheck it.
Okay. Party is going to see. Suppose, for example, now the fraud. You see cyber security. If any problem goes wrong, the police and they will monitor everything what is happened, and they will identify something goes wrong. They will identify from there, and they are going to detect it. Isn't it? So therefore, we need to maintain. They are maintaining some log information between whatever it is happening. So banking sector, even the banking sector is maintaining this structured third party. Means all the suppose, for example, you will tell you all the banking sectors they're relying on RBI. RBI is relying on the government. It is not distributed. It is a trusted. It is centralized system, isn't it? We are trusting everything on each other. Okay.
Yes.
Right. I'll come to you that point. How can we use blockchain in healthcare? There's so many applications are there in the healthcare. I'll come to you that. Okay.
Sir, one doubt, sir. Hello.
Yes. Go ahead.
Sir,
Go ahead.
we are using the third party for. Sir, we are using the third party for transaction. Yes, sir. So, what type of security we are giving for that? We want to trust the third party.
See, now already we are having the certificates, digital certificates. I'll come to you. You pass this question, I'll give the answer to you. May I know what is your ID number? 20, na?
My ID is 84, sir.
84. I'll come to you while I'll discuss that topic. Okay. Now, I am
Okay,
asking
sir.
with respect to trusted third party. I'll give the answers for those things. Okay. Right. Now, you see the
Okay, sir.
anonymous payment. What is happening here is now whatever it is happening here. Now, user A is going to the bank to withdraw the amount or to perform something, and is going to get the amount. Then some user B is going to going to the bank to withdraw the amount and is getting the amount. And the user B is going to the shop to give is going to give and to get the burger or some pizza, which is going to get it. And the shopkeeper again is going to deposit everything which is going to happen. Right, amount will be deposited into the bank. Now, this is a mechanism which we are following now. The money is going in and around, and directly it is going to the bank directly at the end of the day, which is happening. Right now, when you see this concept, now everything is happening based upon the centralized system. We are going to talk about it is a centralized system. Now, the centralized system allows the bank transfer between the two accounts that we are maintaining now. The currency will be printed and controlled by the government. Now, the 84, your answer is this one, is it? We need to maintain the certificate authority. Your certificate authority is a trusted authority, right? These trusted authorities will maintain the security, will provide the security between the users or between the banking sectors. Network certificate authorities which we're going to maintain in order to establish a network between the system which you're going to have, right? All these things now currently, if you see, this is a very important one which we're going to talk about is that there is a trusted third party need to be trusted. There is a trusted third party need to be trusted, which we're going to have. Okay. Now, the centralized system which we are having now, there is some problem because the centralized system is also called as trusted system, right? If you see these figures which we are going to get it, these figures which we are having, all 5 figures is based upon some trust, right? Now, if you see if you see this figure, we are going to have it. This person is trusting this verbal, and this person is trusting all the 3 persons, isn't it? Which we are going to have it, right? And these 2 persons are trusting each other. And see, mother is touching his kid, and his kid is trusting the mother. And see, if keys which you are going to have it, the keys which you are trusting each other, which is based upon the trusted system. And if you see all the centralized system which you are going to have it, it is based upon the trusted system, right? Now, what are the problems with the centralized system that we are facing now? That's a question now which we're going to have it here is see. Now, central party maintains large database at one place which attracts the attacker. See, when we keep huge amount of information at one place, there is a chance of getting more hacking, right? So that's a basic concept. Central party maintains large database of information which attracts the attacker. That's a major first problem. Then central party may be hacked and it affects the millions of people, right? Suppose, for example, if one banking is hacked, and immediately it affects the millions of people who are the stakeholders to that bank. And the major problem with the centralized system is the single point of failure which we are going to have, right? Single point of failure that need to be addressed in all the levels with the centralized system. Right. Therefore, the trend is moving. If you have seen my first slides, because we are talking about the technology which is relevant to decentralized or distributed system. Right. Now, our main aim is now. If you see, can you see here? If the internet is a distributed system, that's why it is evolving much faster rate. It is exponentially increasing, right? The internet because of the distributed system. Right, it is not a centralized system. Now, the trend is moved from centralized system to distributed system. Now, we'll try to see what are the advantages with the decentralized system or distributed system. How can we overcome the problems of a centralized system? Now, our main goal is to have a distributed trust rather than going for centralized trust. We need to go for distributed trust. If you see this one, the weakest link security is having only a single key. Now, for only it will be used for only a pair of people. Now, if you go for a little bit strongest link, where banking sector will be there, and only for the smaller group. Now, we are not interested with this smaller group, because as the people who are using larger, if you take now, internet will be used by larger community. Now, if I want to provide a distributed trust for the internet, now definitely we need to go for larger group, not for the smaller group. For that thing, we need to have strongest in the security for the larger group. Now, how to provide strongest link security for the larger group in order to ensure the distributors, in order to ensure the distributed trust. That's the biggest challenge. Now we are going to have. Okay. Now, just we'll have tried to see very quickly. In 2005, we are using one of the beautiful centralized system is a cloud. Right? If you see, a cloud is a centralized system which we have started from 2005. This research was started, but we started enjoying this cloud computing concept from 2010 onwards. This is an open access network with the centralized cloud, and the future is all about very soon. Already a lot of research work and a lot of people are involved to enable this one. Is a open access network with a distributed cloud, which is distributed cloud. So therefore, the trend is already there from centralized system to decentralized system or distributed system. Now, see, that's a point here, making everything decentralized or distributed, where there is no single point of control or single central point of control. That's a very important point. That's a very interesting one. So that any person can send to any person without the government is involving. Therefore, there's a problem with Bitcoin. How without the government, without the trusted third party, or without the monitoring, any person can send any amount of that. Therefore, Bitcoin is initially they're reluctant to use this Bitcoin concept. Later, government are reforming and they start changing the things. Okay. Now, if you see, this is a centralized system which we're going to have it, and this is a distributed system. Morning session, the other resource person is discussed about peer-to-peer network or distributed system, which we're going to have it, peer-to-peer concept, which we're going to have it. Now, the advantages with this one is in centralized registry, single point of failure, easier can happen. The opposite of this one is, it is a distributed or decentralized, which you can have it, right? No single point of failure, and it is very difficult to hack. May I know why it is very difficult in decentralized system? May I know why it is very difficult to hack the decentralized system?
Because changes are distributed at all the points.
Since the data is distributed everywhere.
One after the other, please.
So data is transmitted over the network.
Yeah.
No one can specify the required data is there in which machine.
Okay. If the hacker want to attack the system, right? Now one person is there because one is monitoring. Now everyone is monitoring. What is that?
They can either
See, if everyone is monitoring, now I'll give a small example. So what I am saying is now everyone is monitoring everyone, whether everyone is concentrating in this class or not. If I am only the person who is concentrating and everyone is listening, means only one person.
The decentralized.
It is very easy to hack it, but it is very difficult to convince all the members. Suppose one person is left this one for 5 minutes, and if we want to join, right? Only thing is he will take the admission permission and he will ask us, sir, my network is not working, please add me. Right? He will add it. Now, if you implement a distributed system, means everyone should accept it. If one person should join, means everyone should accept it. Then it is very difficult to convince all the people, and it is very difficult because manipulation is very difficult, especially in distributed environment. So therefore, it's very difficult to hack in distributed environment. So that's one of the best example I can give you. Okay.
Sir.
Yes.
Sir, when come to the decentralized, it is very difficult to hack. So you say no. So whether the address is not stable, sir. So when come to the decentralized,
no, the address concept is not a concern here. See, when you are sending the data over a network, IP addresses are visible and it will be logical. It doesn't matter because if you are going for privacy concept, that is a different, because you're going to take half part. If you are using IPv6, out of IPv6 64-bit, you're going to use right conventional mechanism. Remaining 64-bit, you can hide it. That's a different concept, but that we are not implementing. Hacking a system is not relevant to your address. That's a different concept. Now see, the hacking system is I'm hacking your information, not your network.
Most of the
Which is
information
residing in your system. Pardon?
Most of the information can be translated in only depend upon the network address, sir. So we can easily to hack the system now.
See, see, there are 3 types of addresses are there. If I know the network, I can know the system.
Okay.
If I know the system, if I can know the application where I can get it. So therefore, there are 3 different types of addresses are there. Network address will be for all network. Now from that network, I should know even the MAC address. Once I know the MAC address, then I should know what type of application, what type of data I require.
Okay,
isn't it? So not only with the help of network address, I can hack it. That is a different concept. Addressing is different concept, right? To know the network, to identify the system, anyone can know it. There are so many tools are there to identify the IP addresses. But our main to have is, suppose, see, one is thefting. If I keep CC cameras on each and every home, on your home, then I can see very effectively where who is listening, who are not listening. If only one CC camera is there, then everyone is monitoring, it's very difficult.
Okay, sir.
Isn't it? So that's therefore it's very difficult to hack, especially. I'll come to a clarity about those things in detail when it comes to the things.
Okay. Okay, sir.
Right. The next thing which we are going to talk about is any other? Someone is speaking.
Sir, you show the diagram now for the decentralized. So if it is any person can be left at, means we can easy to hack, or it is very difficult to hack, sir.
It's very difficult to hack when you have a distributed decentralized system. I'll come to you that problem. I'll come to you.
If one person is left at now, with the diagram will be make it with the centralized, sir. No.
But I'm not getting your question.
Sir, if one person is left in this circle, so whether in diagram decentralized, you show the decentralized diagram now, sir. So when one person is left now, it will be make it a centralized, sir.
No, let me tell you now. Assume that we are in decentralized system. Assume that we are in decentralized system. Now one person left it, doesn't it? Now I'm explaining one slide. I explained one slide, right? And later after 5 minutes he arrived. That slide will not be visible to him, isn't it?
Okay, sir. Yes, sir.
Though if you go in centralized system, everything is visible. If he comes, that doesn't matter. Okay. Now I'll come to you in clarity about your system. Your example, I'll come to you in detail. Now we are going to see, right, once the centralized to decentralized system, now we are going to have it. Morning session, you have a clarity with the decentralized ledger, right? Already you have studied in DBMS the concept of transactions, which you are going to, which you already discussed, right? Now we need to see these are all various ledgers which we have come across in day-to-day life or in reality. This is a centralized ledger. As we know, what is a ledger? Means we are performing certain set of transactions and we are processing set of transactions on a ledger. So therefore, here this is a centralized ledger, and this is a decentralized ledger which you can have it, right? And this is a distributed but in centralized cloud computing. Now we are going very interested with distributed ledger. Now here, if you observe, every person will maintain a copy of that ledger. Every person will maintain a copy of that ledger. All right. Suppose, for example, if one person, now the people who have not understood the concept, please understand this one. Suppose if one person, the other person is hacked this ledger, and is updated, right? Someone has updated, then that fellow will not get that updated information because of the credentials, cryptographic credentials, which are the part of the network. That is all about blockchain. So therefore, we are going to talk about the distributed ledger now. right? Which is very difficult to hack because everyone will maintain the copy. Everyone will maintain, every peer will maintain their own copy of that ledger, right? If anyone want to update that information, or that updated information should be available to all the members of that network, all the members of the network. Okay.
Okay, sir. I
Now, if you
understand,
have
sir.
seen, yes, right? If you have seen in centralized system, right, all these things will be maintained at the centralized level. Means user A information, user B information, user C information, user D information, everything will maintain in a centralized ledger. As we know that there is a problem with centralized ledger, single point of failure, easy, it can be hacked and it will affect the millions of people, right? So whenever, now the question comes to you, I'll give a challenge to you: how to update the ledger in a centralized system? See, in directly in conventional mechanism which is happening now, you are going to get a message from the banking sector which is maintaining centralized system. Yeah. Now bank is under, because from 9 o'clock evening today and tomorrow morning up to 9 o'clock, the bank will be under maintenance, so no transaction will be operated. What's the meaning of that? They are updating the transactions in their centralized database, isn't it? When money is coming and when money is going here in a day, right? We need to trust the trusted third party for updating the ledger, right? For updating the ledger, right? Therefore, they will take a whole day for maintenance, right? One full day, morning, whatever the transaction is, it has been happened. They will take some time in the evening for updating the ledger, right? Therefore, it is very slow, it is very expensive, and it is very easy to hack. That's a problem with updating the ledger, right? That's why if it's maintained by the bank or in a personal computer, the problem is what? It can be easily hacked. It can be easily. So therefore, our main motto is why we are interested with distributed ledger means we don't want to trust any person or any trusted authority to maintain the ledger. I don't want to tell to any person to maintain my ledger. I'm the person to maintain my own ledger, and that's important. So therefore, for that, we need to have, everyone will keep a copy of that ledger. There's some drawbacks are there, like replication is there, but a lot of research work need to be done how to replicate the data so that it will be preserved with minimal overhead. So everyone keeps a copy of the ledger in distributed ledger. So everyone checks, everyone else changes to it. Everyone checks, everyone else changes to the mechanism, right? So if you see this distributed ledger, A will maintain its own copy, right? A will maintain the copy, B will maintain the copy, C will maintain the copy, D will maintain the copy, and E will maintain the copy. So this is all about distributed. This is all about, you mute few members, not muted. Okay. Right. So therefore, if you see here, how to challenge means, now here the biggest challenge. Now I'll give a small example which has happened in Bitcoin. Now in our group, almost 120 members were there. I divided that 120 members to 60 plus 60. 60 members is one group, 60 members is another group, another 61 to 120 is another group. Now what I have given is, a biggest challenge I have given is, now I'm having 1 million transactions. I'm having 1 million transactions. Now what I'm saying that who will update the ledger? Whoever, group A is there, group A will be there and group B will be there. The prize money is 1 lakh. Whoever update the ledger and it will be stored in all the fields, then they will get a 1 lakh prize money. Now there's a challenge I have given to two groups. Now they will start mining it and they will update the ledger, and definitely they will treat that we are successful to update the ledger. Then the prize money goes to group A. Similarly, now I'll increase the proof of work. I'll go for 1 million, like, or 100 millions of transactions to be updated. The prize money is 1 million. Like this, we start updating the ledgers by creating the challenge in distributed ledger. Okay, in distributed ledger. That's a Bitcoin which we are going to work it out of that. So what are the advantages? What are the technological advantages that moved from centralized system to decentralized system? Is it is more reliable. It is more reliable, right? And it is more fault tolerant. That's the first advantage. It's a fault tolerant. The second one is more secure. How we are going to provide more security, that's next we'll see. And it is more attack tolerant. It is more attack tolerant. The third one, no single point, no single bottleneck, so that it will be faster. No trusted third party, no intermediary. Therefore, it will be very fast between user A and user B. Right? No single point of control, no monopoly. Therefore, it will be very cheaper. No single point of control, no monopoly. Therefore, it will be very cheaper. Very cheaper. Right? So, therefore, to build such a total environment, to build a decentralized system with no central authority, the blockchain is the one way to do this. Right? Blockchain is a technique or technology which makes use of, which provides the solutions for all these problems. These are the problems where we have a centralized system. The blockchain technology will provide the solutions for these problems. Right? I'll pause for 1 minute. If you have any doubts up to now, you can ask me so that I can go to the next topic.
Excuse me, sir.
Yes.
In decentralized also, we need to have trusted third party, I think.
No, not required.
No, sir.
Not required. That we are going to work in the form of smart contract. Okay. Suppose, for example, now I'll give a small example for your question, sir. Suppose, for example, now we are having almost 130 participants, and 130 participants are, suppose, for example, 130 participants, you're working in different colleges. You have your principal, isn't it? And maybe you are head of the department, whoever maybe head of the department or principal. Now, what I'm going to create, I'm going to create a distributed environment among all the principals. Whether all the participants are involving, means you're, suppose, for example, in your college, 2 members or 3 members participated for this FDP. Now, your principal will take care of your 3 members. The other principal is going to take care of their members. And all the principals will be communicated whether the FDP is going very effectively or not. So, it is nothing but, instead of going for single one, we go for multiple members. You are able to follow. Example.
Yes, sir. Yes.
Hello?
Yes, sir. Yes, sir. Yes.
You got it, my point?
Yes, sir. Yes, sir.
It's not a single. Now we are going for distributed. Distributed means multiple members will be there.
Yeah,
so
yeah.
I can't mislead it because yes, I can't. One validator is very easy to manipulate it, but not with multiple validators. Multiple validators is very difficult to convince. You got my point?
Sir. Yes, sir. Yes, sir. Thank you, sir. Thank
Any
you,
other before I proceed?
Sir, when come to the centralized and decentralized.
Yes.
Come to the centralized and decentralized. So we are comparing the traffic. The traffic will be more active with the decentralized, sir.
No, I'm not able to. Your voice is not clear, sir. Please, can you repeat once again?
Sir, actually, when come to the centralized and decentralized communication, so whether the traffic is very high for compared with the centralized, sir.
No, I'm not clear. I mean, what is the question you want? I mean, actually, I'm not clear with your question.
Sir, whether the traffic is very high for the decentralized, sir.
What is high? Traffic. Acha, okay. Now, how can you say that the traffic is because internet is your internet is there. Your internet is distributed system or decentralized distributed system, no? It will distribute the traffic with multiple things. So there are so many ways are there how to maintain distributed. We are not talking about the traffic or congestion which is happening in distributed. Now I'm talking about why the trend is moving from centralized system to decentralized system. Of course, there are some challenges are there in decentralized system that need to be resolved, right? Which is happening, which is a lot of research work is happening in that.
Okay, sir.
Traffic is a big that is different. Maybe how many number of members are the part of the network and how the traffic will be distributed. That is a different concept which we are not talking about now. Okay.
Okay, sir.
Shall I proceed now? Any other questions for up to this?
No, sir.
Oh.
Hello.
Yes, ma'am.
Sir, in decentralized, we have different parties are there. We are storing data in multiple places. So before going to update
not
the data,
multiple place, but in a single place. Only one distributed decentralized ledger means for whole, all the data will be stored at one place, not multiple places. Every person will have a unique ledger, a unique distributed ledger, common unique distributed ledger. That will not be distributed. You can't have multiple ledgers on your own system. Only unique ledger. That ledger will be maintained by all the people. Same ledger.
Means that is
Okay,
shared.
before updating that data, everybody need to involve that one. Everybody need to give the acceptance.
Yeah, I'll come to you that point. I'll come to that point because it's too early to tell that concept. Yeah, I'll give an answer to you. Now, everyone see, for example, now I'm sharing one slide to you.
Okay.
Suppose I'm sharing now 12th slide. It means that you already received 11th slide, 11 slides to you. Everyone, now I'll ask a question whether all the people have listened 11 slides, and if no doubt in that means yes, everyone will tell yes. We received 11th slide and we are ready to get 12th slide, isn't it? Means you have already updated 11 slides and you need to update 12th slide for maintaining the consistency. You got my point?
Yes, sir.
Yeah, that consistency need to be maintained, especially as a blockchain developer, right? Consistency need to be there for all the feeds in the network, right? One cannot be maintained 11th slide, one cannot be maintained 14th slide. The consistency should be there among all the slides. Okay. Right. Now I'll proceed to the next coming these things. Okay. Mute to all the members, then I'll go to next. So therefore, now we'll try to. We have covered up to now, right? Online transactions, centralized to decentralized, and centralized to distributed ledger. Then why the industry? Because we are not studying. We are studying a very good technology, where it will provide the promising solutions for various solutions which we are facing now. This industry technology. It is not a academic oriented technology. It is an industry oriented technology where it will provide a lot of promising solutions. Therefore, whether the industry, ICT industry is interested in blockchain technology, yes. Already 52% of the companies they started working on blockchain technology. So therefore, why the industry is working on this blockchain technology is this very interesting one. So that's why it is a disruptive technology and a new model. It's giving a lot of solutions to the problems which we are facing in existing way. Potentially broadly applicable. It's something like a database replication or network information replication can be done very effectively. Right, we can have it already. I think in University of Berkeley, they started working on IPv6. Right, like one question, one participant asked the question: IP address hiding. Yes. IP address, who is using which IP address and from where the data is coming, from where data is going. They're maintaining at the network layer blockchain. If you have gone through the University of Berkeley, the blockchain, they are having center of excellence. They're working on IP networking blockchain, right? And if you go to Ireland, and if you go to, if you have seen certain white papers, they're working on smart agriculture using blockchain technology. Right, there's so many applications which are going on. A lot of use cases are happening. New services they're providing on the blockchain technology. Right, therefore it is a foundational. It is not a fundamental technology. It is a foundational technology. Means from last 40 years, what are the problems we are facing? It is going to provide some promising solutions, but still a lot of research work need to be done on this this technology. Okay, and many more reasons why we are using a blockchain technology for this one. Right, for that now, therefore a blockchain is ready for the business because it's a shared ledger. That's the first one. Is it's a shared ledger, just already given. And why it is a shared ledger? Because only one thing we need. There is no concept of writing, only append. Only append, because append only it is possible. If some mistake goes wrong, if we are going to validate the transaction, if it is not correct, we are going to throw away. And then if it is validated by all the members, then only we'll append those transactions into the block. And one of the important major problems which we are facing, for example, you take Facebook, if you take Google, they are maintaining centralized access control lists. Now, the privacy is the biggest concern. Now, how to provide solutions with respect to the privacy? Blockchain is going to provide a privacy but not only the transactions will be secured, authenticated, and verifiable. Tomorrow, I'll show you one of the permission blockchain network, how the transaction can be secured, how the transaction can be authenticated and from the peers, and how can we verify the transaction whether the person has sent this one. So privacy can be ensured. And as I told you, it is a course, multidisciplinary course with respect to computer science. We can apply consensus mechanisms. Like the consensus mechanism is also called as an agreement protocols. We need to have an agreement. So if, for example, your principal has given the agreement because our coordinator has sent a mail to all the principals making an agreement, all the participants should attend this program from the first day to 5 days without leaving any session. Then that's a consensus. That's an agreement between your principal and the coordinator. And your principal has taken the agreement from you. Once you have joined this FDP, right, you should attend all the sessions without leaving any session. That's the agreement. That's the agreement for all the participants to run this program. And that's why that consensus will work on smart contract. What is a smart contract between you and principal to coordinator? There's a piece of code which is running on your brain, right? The piece of code which is running on your principal mind, whether all the participants are attended or not, whether all you also, if you left for 5 minutes also, you will be rushing and you will join, because your smart contract on your brain will be running. If I miss 5 minutes, I may not get certificate. If I miss 5 minutes, my attendance will be less than 80%. So this type of smart contract will be running on this one. So depending upon the application, we'll try to use this smart contract. Okay. So, and very important one is a confidential transactions from different users will try to use the confidential transactions. Right? We are not using any cryptocurrency here. No cryptocurrency is required. We are not using any Bitcoin concept here, or we are not interested with that. So therefore, no cryptocurrency, and it is easily programmable. There are so many ways are there to programming on these concepts. Okay. Now, these are some of the advantages of the blockchain technology, as I told you. Now, whatever the session I've given from last 40 minutes, now it is not centralized, it's distributed. No intermediary is required in blockchain. As a first, there's the next advantage. It reduces the cost because I am not paying any amount to trusted third party. I can maintain my own permission blockchain. So therefore, cost will be reduced. It is a transaction based, and all the transactions will be stored in the form of block. So therefore, it is a transaction based. And then the next one is a record keeping. Will maintain a high record log information will be maintained, so that a hack cannot be done. Even a hacking is happened, all the members can view that using record keeping, or powerful audit trails will be there for that record keeping concept which we are going to have it. Okay. And one of the advantages of blockchain technology where we are facing now transparency. Now, currently, there is a lack of transparency in the whatever is happening. Now, we need to, if you are applying blockchain technology, everyone is transparent. With whatever, I'm very clear. Every participant is clear to attend this FDP because they are transparent. They are transparent with each other. So, blockchain is going to provide one of the important parameters, transparency. Not only the security, not only the privacy, not only cost will be reduced, no intermediate authority, but transparency will be maintained. Efficiency, of course, efficiency will be improved. That's one of the important concept of blockchain technology. And no need of trusted third party. No need of the trusted third party, which we are going to have. Okay. Before I go for 5 minutes break, if I'll take 5 minutes break, and I'll come to the introduction to the. I know morning session. I think introduction part is already over. Now, if you're shall I skip the introduction part, or you want to tell before I conclude? You can tell me.
Hello.
Yes.
Sir, you are telling about transparency.
Yeah.
Yeah. Whenever we can think about transparency, that means in peer-to-peer networks, all the transactions are stored in distributed manner.
Yeah.
So can it possible to give India government allowed for putting blockchain technology in income tax department?
Yes, absolutely. Not only in not only in income tax, right? Insurance companies, they can use blockchain technology. Government can instruct CBI can because the CBI investigation is going to happen. Assume, for example, Now the transfer, whatever it is happening, CBI investigation, every person can view it, whether the investigation is going to happen effectively or not. See, we can apply this blockchain technology for many applications.
So private insurance companies, they may be implement, but for the consideration of the income tax department or the other audit type of things, can government will be allowed those type of things to blockchain has to be implemented or not? That is
It's
the
a government decision to implement such type of things. So that's about it. Government should take a decision to implement because the technology is there.
Yes, sir. Yeah.
The technology
Yes,
is
sir.
available. Now, only thing is that now already that's why they have taken a very good initiation for smart agriculture. IoT with
Yes, sir.
blockchain,
Yes.
they started. There are a lot of projects they are proposing on blockchain with IoT to enable this transparency issues, right? Like land registrations. They started working
Yes,
on
yes, yes.
these things, right?
Yes, sir.
So
Yes,
they
sir.
started working in
Telangana
the
government
initial
also
stage.
started.
Yes, yes. It's the initial stage. A lot of work need to be done. It's the biggest challenge for the even teaching community to update all these type of technologies to get updated.
Sir, today or
Sir, one
tomorrow,
question,
can
sir.
you give some installation process for the Hyperledger Fabric or something R3 CODA like this? You can implement or you can show anything.
No, I can show, but actually I requested you people to have Ubuntu. I recommend.
Yeah.
I
Yes,
told
sir.
actually because you should
Yes, sir.
have
Yes, sir.
tomorrow. I'll tell you how the cryptographic primitives will be used in Hyperledger Fabric. In ECC, how we are going
Yes,
to
yes,
how the
yes.
public keys, how the hash values will be there, how it will be distributed.
Yeah.
I'll send a video. I'll share a video to you where Hyperledger installation will be happen. So if you practice, that will be good.
Yes, sir. Yes, sir.
I'll give some examples with the Hyperledger Fabric, how they've implemented. Hyperledger Composer is
Yes,
there,
sir.
Ethereum is there. But I'll show one
Yes,
case
sir.
study to you people. Tomorrow I'll do it that.
Okay,
Or
then.
maybe
Thank you.
in the
Thank you
class
very much,
test,
sir.
I'll share the video. Okay.
Sir,
Okay,
one
sir.
question,
Thank you,
sir.
sir. Thank you, sir.
Yes.
Sir, one question, sir.
Yes.
Hello.
Yes. Go ahead, sir.
Sir, if any institute or any company wants to migrate to blockchain, should they spend lot of money for this new technology or existing
Not required. Existing technology is
can
sufficient.
be
Existing
used, sir?
infrastructure is sufficient.
Okay.
See, it depends upon their requirement. If they want to have a new requirement, they can go for their new requirement. But computational overhead is a little bit high in blockchain. But for sufficient minimum facilities is there, we can establish a blockchain. Suppose, for example, we did a project on eradicating the academic certificates, duplication of the academic certificates. We are getting a lot of fake certificates, isn't it? Now, how to eradicate and verification, especially in Telangana, there are a lot of certificate verifications happening, isn't it? And especially the faculty community, they're facing a lot of problems because they're sending a query, but in the university is not responding. They're taking a lot of time for responding. Now,
Yes,
to
sir.
overcome this problem, we have implemented a blockchain technology where the certificate will be there and immediately verifier can verify it. Issuer can issue it and verifier can do it very easily within very few of seconds. So we implemented the same academic certificate verification. Tomorrow I'll give that case study to you.
Yeah. Okay, sir. Thank you, sir.
Yeah.
Hello,
Right.
sir.
Yes.
Hello, sir.
Yes.
Sir, whenever we go for the transaction from source to destination, we have to give any key, sir, public key or private key, something we have to give for the security
Now,
purpose.
see, I'll come to the technical in the next session, another session, because if any transactions, because that cryptographic primitives need to be applied, that I'll come to the next morning session. I think Sir has covered blockchain introduction, but I'll go in detail. I'll go in detail about blockchain, internal architecture of blockchain. I'll go for that. How the transaction is happening, how it will be stored in the blockchain, everything I'll come to in the afternoon session. Yes, Ashwini madam, yes, we can do in healthcare department. I'll give one healthcare, e-healthcare, like electronic health records can be implemented very effectively. Yes, sir. Hello?
That only, sir. Sir, for whenever transaction, hello?
Yes, go ahead.
Sir, audible, sir?
Yes, it's audible. Please go ahead.
Sir, we have to use in the digital signature, sir. So for what purpose we are using the digital signature?
sir, I'll come to those points in the next after 5 minutes. I'll come to the technical aspects. Right, I'll tell you clarity about the digital aspects. Okay.
Okay, sir. Thank you, sir.
Right. Yes, Ashwin madam, yes, we can use in healthcare department. There are so many applications are there. One of the best example is EHR, and Dr. Anuradha madam, yes, we can use in renewable energy sector, because we go for electrical electrically smart meters and renewable energy sector we can use very effectively. Right, we can effectively implement on this. You can see certain papers, blockchain technology using renewable energy sector. There are a lot of potential is there in that, because to ensure the transparency, security among this one.
Okay, sir. Thank you very much, sir.
Yes.
Sir, one question. Sir, shall I ask one question?
Yes.
Sir,
Go ahead, sir.
the system which are going to be used for the blockchain, whether it is going to be dedicated or it can be used by the users.
I'm not getting, sir. Please once again come. Please repeat the question.
So the system which are going to be used for the blockchain purpose,
okay,
whether it is going to be dedicated mode or it can be used by the users.
See, now currently whatever it is, if you take Hyperledger or if you use Ethereum, whatever they are using, now your system will work like a distributed environment. Your system itself will work like a distributed environment.
Okay.
Like you can create virtual machines in your virtual operating system. Is that no?
Yeah.
VMware. You can your system, or you can establish a system with multiple distributed you can have. That depends upon your environment. Means with the 10 to 15 system, you can establish a distributed system, or a single system can be established as a distributed system. That depends upon your application oriented. If you want to do.
Okay, thank you, sir.
Hello.
Thank you, sir.
Okay. Thank you, sir. We'll have a 5 minutes break and then we'll come back. Questions Banker national batch active participant interest.
Hello. A small request to the participants. I have seen some more few people not change their display name with their FID. I request them to please change their display name with FID. For example, here Shiva Prasad sir, Jayashree Murali Iyengar, Ashwini. Okay, sir. Sorry, I'll change it. Aradhana.
Haji.
You please keep FID followed by your name. That is not a problem. If you want to display your name, you can display, but please keep the FID. NITBT followed by 3 digits. In the brackets, you can write your name if you want.
Yes, sir. Yes, sir. Thank you, sir. Sir.
Please do that. Banod Prem Kumar, Shiva Prasad, Jayashree. I can see few people, they have not changed their display name with FID.
Where we can change it, sir? At the entry
Just
point?
go to the people, you right click on your name in the people.
After completion शुरू नहीं हो सकता
If you right click, you can get an option your mail and name and email. There you can
भाई after completion course academy
Any problem in changing the display name?
Sir, how can you change the name, sir? Sir?
Sir, you go directly to your name in the people.
Three dots are there, sir.
Sir, how can I change my name?
Sir, you go
Sir,
to the people.
Sir?
left hand
Hello?
side now there's an option, edit your info. Click on
Left
the
hand.
three dots. Yeah.
Yes,
Click on
yes,
the
sir.
three dots. Edit your info. Edit your info.
Support is there. Support
And
and go
enter
to
your name. Pe change it, na?
Hello.
Hello. How I can
If you are
change
using mobile, if you are using mobile, sir, there are three dots on the left hand side, extreme left hand side. Click that one.
Click on the screen
audio options. Edit your info option is there. Help and feedback option is there. First, click that edit your info.
support
and the screen. Sir,
click on the screen,
just
click on the screen and click on the
screen.
three dots that are there on the left.
three dots. Visible?
Three dots only. There is no support and go to meeting is there.
No, you're using phone, sir.
Huh?
Phone, you are using your phone?
Yes.
So there are three dots. Over there, sir, you can't see any edit your information, edit your info tab.
Are you using laptop or mobile?
Laptop, sir.
Laptop, you have to go to the corner of left side, top corner. Go to meeting, right? Go to meeting.
Left
corner.
side. Yes.
Left side top corner. Yeah. You click on that.
Okay. Edit
There
name.
you can edit your name and email.
Name. Okay. Name is
Yeah.
there and is there.
Yeah. Name, instead of name, you have to type the ID which is given to you.
Because I don't know my ID, sir.
No, you should be knowing my NIT BT number.
So Kumar Sami sir will provide you the ID.
No, they have sent one Excel sheet. Right. They have shared one Excel sheet wherein your ID is available.
ID number, how much is that?
You refer your Excel sheet, sir. Excel sheet.
ID number.
For knowing the ID number, refer Excel sheet.
Hello.
There is Excel sheet. Sir, what is the, madam, what is the ID number?
Sir, what's your name, sir? I'm having Excel sheet. I'll search and tell you, sir. What's your name?
Kumaraswamy. Dr. M. Kumaraswamy.
Okay, sir. Wait.
Kumaraswamy sir, hello.
Yes. Yes, sir.
Sir, you have not filled the Excel sheet, right? So your name will not be there. Will you?
Yes.
Hello. Kumaraswamy sir will provide you the ID. The remaining participants except Kumaraswamy sir, please change your display name.
Yes, sir. Hello. Sir, I have changed my display name.
Yeah, Sir has arrived now. The session is about to start. Please keep mute on your audios.
Sure, sir. Sure, sir.
Yeah. Yes, I've seen one question from ID number 10. Yes, we can use the blockchain technology for wireless sensor network, but we should know that because wireless sensor networks are high congestion nodes, now we cannot apply at the sensor level, but we can go for either sync level where it will have its sync nodes can be acted as the validators. Like IoT, IoT with the blockchain can be implemented as an example. Sensor networks with edge computing levels we can easily implement blockchain, but you need to do some lot of research. There some papers are available how blockchain can be implemented for ad hoc network or Bluetooth. We can apply the same thing with a wireless sensor network. You can easily do for that also. Okay. Now in this session, we'll try to see the introduction part to the blockchain technology, and some of there are 4 important key concepts of a blockchain is there. We'll try to emphasis on, especially I'm going to emphasis on the security aspect of blockchain, because cryptographic primitives of blockchain will be used along with the cryptographic primitives. Some other key concepts is required for blockchain. A coding part will be there, and distributed computing will be there, and the DBMS concepts is required. So therefore, some of the key concepts which is available for these things, right? Now we'll try to see in this session introduction part of the blockchain. I'm not going to, because in the morning session, Sarah has covered, other resource person has covered the introduction part of blockchain. Just I'll give a review of that blockchain concepts, and then we'll try to see, we will dig it into the blockchain internal architecture. So how to find and transfer a block or a blocker to all the members. All right, and we'll try to see the blockchain internal architecture. That's a very important one, and how to build the blockchain. We'll try to see. This once we complete these things, in tomorrow we'll try to see some hands-on. So that I request all the participants, you come with the laptops with Ubuntu. Ubuntu, if you install with virtual machine, doesn't matter. If you come with the mobiles, it's very difficult. So to have a session interactive and through hands-on, then you can learn some certain important aspects of this one. So I request you people, you try to install the virtual machine, and along with Ubuntu, that will be good for you to do the hands-on approach. Okay.
So can we use an online platform, sir?
You can use it, but see, online if you want to do some research work, or if you want to give some project to the BTech students, you can use the laptop where you can store the data. Online, it will not store the data for you, isn't it? I'll give online to you, and you're going to practice it, and you're going to leave it. That will not you. I'll show online. That is for me, it is a 10 to 15 minutes time, isn't it? But when you practice on your own system, even after end of this FDP, you will try to practice, and you will get exposed of the blockchain technology. That is my side sincere request is. I'm giving one day time to you tomorrow morning. If you have a Ubuntu, it's well and good. If you are not having, try to have a virtual machine, download it and try to install it, so that you can practice even after this FDP. Okay. Shall I proceed? Yeah. Now, as you know that. Now, if you see this, here the introduction to the blockchain, just I'll give a brief introduction, because it will be redundancy in the morning session also you have studied this, and you already given wonderful answers when I asked the question of blockchain. It's a distributed ledger technology. The other name for blockchain is DLT, distributed ledger technology. And all the records, distributed ledger records, like ledger will consist of all the transactions. It's a DBMS concept, right? And it's a very important one. Just I told you, no. Now we started second session. We have started second session. Second slide we are here. Second slide. Now, whether you are all on the second slide or you are in the first slide, I want to know it. So therefore, there is a concept called dictionary. I think in your data structure you have studied the concept of dictionary while studying data structures. There is a concept of key value store, right? For storing every value, we require a respective key, because that key will give the address for a particular value to store. So here, if you want to have a blockchain, for every value, whatever we want to store, for every digital information, we need to have a key where a particular location will be stored. So this is called as a key value database with the current state which we are going to use it, especially in Hyperledger or in Ethereum. We are going to use this type of concepts, the technique which is going to have it. The next one which we're going to talk about is we know that blockchain is a decentralized or decentral peer-to-peer network of nodes. One-to-one communication can be happen, and this can be distributed it can form a network of very huge level. Scalability will not be a big problem in such type of networks. Okay, I'm going a little bit fast here. Aishwarya Garu, I'm going a little bit fast.
No problem, sir.
No, I think I had please flow. All right. Okay. All right. I'll be a little bit slow for that. That's not a problem. See, now this a few participants asked the question, right? The blockchain is we call them as it makes use of it used internally. It is a part of Bitcoin, and Bitcoin is nothing but a cryptocurrency. We call them. Crypto means secret. Secret, that's it. Now the underlying security, it has built-in security. Blockchain has a built-in security. How the built-in security means? It's a public key cryptography without a central authority. It's a public key cryptography without a central authority. That's what we'll try to concentrate on, this public key cryptography without central authority, how the blockchain is going to use it. That's one of the important parameters which we can have. Right, and all the transactions or any transactions will be added, and it will be validated by the multiple entities. That's very important. Now, before it should be updated, it should be committed into the databases. All the validators, means for example, in our case, all the principals need to be updated, need to give the information to the you. So therefore, then only it will be validated. Once it is validated, then it will enter into the multiple entries. Okay, so therefore this one is there. Okay, right, therefore we call them as, now the solution for our concept is here, the blockchain is nothing but a digital trust. The blockchain is equal to a digital trust. Therefore, from my previous session, if you have seen, blockchain will provide a distributed and digital trust is nothing but, yes, blockchain is going to provide a digital trust. Therefore, there's a solution for almost all the problems which we're going to have. Right, now we'll try to see quickly about this introduction part. All the transactions are stored in a ledger in a decentralized manner. That's why it's we already given the answer for this one. Blockchain is a distributed ledger technology, so that all the transactions, whatever we're going to have it here, now if you see here, right, it's a distributed ledger technology. All the transactions will be stored in the distributed ledger, and the major advantage with blockchain is no single entity has the exclusive ownership. Like in centralized system, right, there will be exclusive ownership will be there. In distributed system, there is no concept of exclusive ownership will be there, or monopoly will be there, or control will be there for a record of information or a transaction. That's the beauty with the blockchain technology which we are going to have. Now, if you see this figure, the block 1 is linked to the block 0. Block 2 is linked to the block 1. Block n minus 1 is linked to block n minus 2, right? Block n is linked to the n minus 1. So it is forming a chain, right? Which we're going to have it, which we are going to use. So it's nothing but a record of transactions that are captured in a block. And every block is referring to the previous block. Every block is referring to the previous block. Every block is referring to the previous block. So therefore, a batch of transactions are recorded it forms a chain. Therefore, the name is called as a blockchain technology. The blockchain technology. That's why the people are calling as a blockchain technology. Okay. Now, this is a very important. I request the participants please note down it. All right, this definition, the next definition is very important here to tell about that. A blockchain is, I think, a few people are already given the answer is, right? We already studied what is decentralized, and we know that any information that is decentralized, we can use blockchain there, and is a public, but still we can use private. We can also use private, and it's a shared ledger of information that is resistance to a tampering. That is resistance to a tampering. That's a very important one which we need to have it. Okay. Now, if you see this is the definition. Now, I request the people, right? One participant asked the question about digital signature. One person asked about that. Now, you'll come to know clarity about this one. Now, this is a formal definition or the standard definition which is given and the IEEE reference architecture they have given. It's a single linked chain of block. It's a single linked chain of blocks. This is a very important one. Verified signed transactions. Suppose if I want to send a transaction, I'll sign the transaction right to the other. I'll send the transaction to the other person. Other person will verify my transaction. So therefore, we call them as what? It is a cryptographic primitive. It's a public key cryptography where we are going to use two public key cryptographies here. One is signed, another one is a verification. This is a signed, and this is a verification, and this is replicated globally on the millions of nodes, right? And each and every transaction or each and every block or set of transactions in a block are linked with the hash pointer. So therefore, here we are going to use three types of cryptographic primitives. We are going to use three types of cryptographic primitives. One is signature, the other one is verification, the other one is the hash function. I request all the people please note down these three important points. The rest of the next session is depends upon these three things: verification, sign, and hash pointer. Okay. Any doubt regarding this definition? Okay. Okay.
So can you show for the previous definition? You
want previous definition? Yeah.
This one, sir. Put for this one, sir. Wait.
Okay. Okay. Shall I go? Oh. Now you see here, if you see this, if you see that, if you want to change one block, we'll see tomorrow practically. If you want to change, if you need to change millions of nodes to attack a system, to attack any system, you need to change millions of nodes, which is very difficult. Because a ledger is already shared to all the people. If a ledger, if something is happening, everyone will come to know about the shared ledger, and immediately we can easily identify those things. Okay. And these are some of the properties of the blockchain, which in the morning session also, sir, as other research person has discussed. We'll try to see. Now, the first one is it achieves a decentralized consensus mechanism. Consensus means distributed agreement protocols. Agreement protocol from among all the peers, or among all the members in the network. Right? No trusted third party is required, as I already told you. No single point of failure is required. No single point of failure is there. Cryptographically secure, as I already told you in the previous definition. We are going to use signature. We are going to use verification. We are going to use hash function. So those are called as cryptographically mechanism. We'll try to see in the next coming slides how the cryptographic mechanisms will be used cryptographically secure. Right? Hacker proof. We are going to have powerful hacker-proof mechanism like in the form of powerful audit trails. Logging information will be maintained, and all the information will be easily maintained in the blockchain. Right. Now, my question is, why do we need a block? Why can't we store in a, because we are performing a transaction, no? Why can't we have a transaction? Why, what is the need of block? A question to all the participants.
Sir, because we are not accumulating all transactions. Whenever transactions are getting developed, we are doing the things. We are distributing the data.
What is the problem with the transaction? Can we link the transactions?
Whenever we have set up transactions, we are just making a block and distributing now.
No, you don't talk about a block. Is not there. I can link first transaction, second. I like your linked list. First node is linked to second node is linked to the third node. What is the problem with the nodes? Transaction can be linked to know what is the need of going for block.
No, along with the transaction, all the parameters like the header as well as the timestamp, everything together, we are putting it as a block.
That you are talking about a block, because here a user A is performing transaction, user B is performing some transaction, user C is performing some transaction, user D is performing some. Everyone is performing transaction, not the block, isn't it? Why can't we go for transaction linking? Why instead of calling it transaction technology rather than blockchain technology? Transaction can be linked to no.
Readability will fail.
Sir,
it will incur more cost.
Pardon?
It will incur more cost.
More coding.
Cost.
Okay, cost, it will include the cost. Okay, any other?
No, more hashing. Overhead will be there for hashing.
Right.
No, okay, right. Now I'll give a solution to you. Right, the possibles were there, but here if you see now, if you take single linked list, what's the time complexity to find a last node in the list?
Bunch of
n.
Order of n. Worst case is order of n.
Order of n.
Now, to
right.
verify that node, to verify that node, we need to travel n nodes, whose time complexity is very high. Isn't it?
Yes.
That's a major problem which we are going to face. Because if I want to verify the last transaction, I need to search the last node, last transaction, which is very difficult to have it. As the chain increases, the transaction length is increases, and the chain increases, it's very difficult to find the transaction. To overcome that problem, why can't we go for that's the point here? Too many transactions, the chain will be too long. Please. Okay, too many transactions, chain will be too long, which is very difficult for verification as well as finding the transaction. So therefore, to overcome this problem, we combine several transactions of the verified transaction. Of verification is done, we can merge it. We can combine it, not merge it. We can merge it in the form of Merkle tree, and we form a block. Once it is freeze, it will be committed and it is immutable, so that I need not to change that block. So there's the easiest way to do this one with the help of the blocks. If you see this diagram, right, block 0 consists of set of transaction. Block 1 consists of, then you require header, or you require right in this block, or you require some identity, all these things, that the rest of them. But here what we do is we are going to create number of right transactions. It varies depending upon, suppose for example, if you are going for permission, we limit the number of transactions. If it is permissionless, we are not limiting the public, or we are not limiting number of transactions here. Okay. Now this is the block chain which you are going to have. Now you see block 0, whatever we are getting, block 0, the hash of block 0 is linked is there with in the block 1. The hash of block, these two are linked. Now the hash of block 1 is linked with the block 0, block 2, and block 2 hash is linked with the block n. So it forms a chain. Therefore, it forms a chain. Therefore, we call it as a blockchain technology.
That this arrow should be on the right side, or the block 0. Hello? Sir, this arrow should be pointed from block 0 to block 1 or block
No,
1
it
to
is
block 0?
referring now hash 0 block is referring to block 0. Block 1 is referring to block 0. If something, if someone has changed the transaction block 0, right? Block 1 will be changed, block 2 will be changed, block 3 will be changed. You got my point?
Okay, sir. Yes, sir.
If I change block n, it will not affect the block n-1, block n-2, and so on up to 0. But if I change something which is already committed and which is immutable,
yeah.
If I change something, automatically everything should be changed. No? You
Yes,
got my
sir.
point or not? Yes. So therefore, the hash of block 0
sir.
and it is referring to block. Okay.
Yes, sir.
Can you please
Sir?
repeat need for block? Can you please repeat that one sentence? I missed that point.
Now see
What is
here,
the need
the
of block? Why we are putting the transactions together in a block?
Sir, from the previous slide also, sir. From the previous slide, that also.
No, I'm not getting. You're having doubt in this slide or previous slide?
No, from
sir,
the
I am
previous.
158. Yeah, I am getting doubt in this. Why we are collecting? Why we are putting transactions together in a block? I have that doubt.
Right. Let's see, as the single linked list, if you link, we can link the transactions rather than going in a block. As the length of the transactions are increasing, the chain will be too long. Isn't it? The chain will be too long. If why we are going for the binary tree, what is the problem with single linked list? Because in a single linked list, I'm giving an example. In single linked list, traversing is very difficult. If I want to find the last node, I need to traverse n-1 node. Then only I can find the last node. The time complexity in the worst case is order of n. To overcome the problem, because we require a faster way of finding a node, faster verification is required so that I can perform very efficiently. If we take a binary tree where I can searching will be much faster, isn't it? Where the time complexity is order of n. Therefore, whatever the transaction is happening over I can keep in a block and I can give a timestamp for that. This block has been created in so and so time. And immediately I can easily trace out with the help of the header. So therefore, too much of transactions will create a too long chain, which is very difficult to find a transaction and verify the transaction. Okay.
Okay. Thank you, sir. Thank you, sir.
Right. Okay. So therefore, we are going to find several transactions of that. One more person asked the question. Can I know what is that question? One more faculty member.
Sir,
yes, you explained now, sir. That only the previous slide only I wanted you explained it. Thank you, sir.
Yeah, I'll proceed. Yeah.
Excuse me, sir.
Yes.
Sir, please go to previous slide, sir.
Yeah.
So anyway, every group of transactions is called as a block. So every block is mined with its hash. Yes or no, sir? So why hash of block 0 is attached with block 1, sir?
I'll come to that problem here. Here, the hash of block 0 is nothing but the hash of all transactions. Hash of all transactions, that is. It is not the hash of a block, it's the hash of all transactions.
All transactions of blocks.
One after the other, so that it will be.
Hello, sir.
Hello. Yes.
Hello, sir. It is the hash of all transactions or hash of only block 0, sir?
Now, let me listen carefully. Now, see, now we are forming a Merkle tree, right? Okay. A Merkle tree it's a binary tree, right? Every transaction hash will be matched. Suppose, for example, you already know the tree concept. I'll give a clarity. I'll come to that point now. Just please listen here. Very important now. Okay. Suppose, for example, now here we have one transaction. We have another transaction. The hash of these two transactions. This is hash. This is hash 1, hash 2, and this is hash 3, right? Okay. And this is hash 4, right? And this is hash 5, right? Then these two hash values, the 4 and 5 hash value will be stored here. And these two hash values, right, will be stored in 7. Then 7 is nothing but block 0 hash value.
Okay.
Block 0 consists of the 7th hash value. If any transaction will change, the 7th hash value also will getting changed. Right?
Yes, sir. Yes, sir. We got it.
You're able to follow. It's a hash tree. Yes. Shall I?
Yeah, sir.
There is any limit, is there, sir, for?
Yeah, see the limiting, based upon that limit, we are dividing the blockchains into different categories. One is permission, another one is permissionless. In permissionless, there is no limit. Number of transactions in a block can be created as the public requirement. But in permission, we can restrict as our need, depending upon the application.
Sorry, one single person can be transmitted the multiple transactions.
See,
How
in
to
a day,
identify the
suppose for
duplicate?
example, listen, sir. In a day, how many transactions you can create? 10 transactions. 11th transaction. Suppose the banking sector has given permission to you to perform only 10 transactions per day. You can perform only 10 transactions. That is permission. If the bank has given 100 transactions, that is a permission. If bank has not restricted to you to perform 100 millions of transactions, you can do it. That is permissionless or public.
Okay, sir.
So it depends upon the application which you are going to apply.
Okay, sir. Okay, sir. I understand, sir. But what is
Yes.
my question is, how to identify the duplicate of the transaction?
See, for example, now who will identify the duplicate transactions? Some validator will be there. Before
Okay,
committing, there are any duplicate transactions there. The duplicate transaction will be invalid transactions.
Okay, sir.
Every transaction will have some ID. Yes or no?
Okay.
Transaction
Okay, sir.
1, transaction 2, transaction 3. So duplicate transactions automatically it will be initially they will be eliminated by the endorsers, by the validators.
Okay, sir. Okay, sir. Okay, thank you, sir.
Right. Now, if you see this one about blockchain creation, whatever we have is that this is a set of transactions, and it is computation power. It is happening, and then it is forming here, right? And then we create a block, right? And we create a block, and block is linking. Therefore, the blockchain creation is going to happen in this way. Now, this is a very important one here. How we are having this is a log information of all the transactions will be there, and there is a header will be there. That header will maintain the information about that block, and then it will be linked. This hash value is linked here. This hash value is linked here, and this hash value is linked here. Okay. All right. So therefore, whatever we are performing here, it's creating a blockchain network. For one peer. The same other peer is going to maintain same type of blockchain. Third peer is also maintaining same type of a blockchain. Right. Now we'll try to see some of the key components used for the blockchain, which is because the morning session you have already seen the introduction part of that, but I'm putting a lot of emphasis on how this key components is used in blockchain, which we are going to see it. Now, as I already told you, it's a distributed shared ledger, it's a distributed database concept which we are going to apply, distributed computing which we are going to apply, and cryptography, public key cryptography which we are going to have it, because everyone should verify. If you have seen the definition which I have discussed in the previous slide, verification, signature, hash, those are all cryptographic primitives used in blockchain. So I'm going to put a lot of emphasis on, or will try to concentrate on, the cryptographic primitives. And if you are interested to do research on, you can use on distributed computing in the form of consensus mechanisms, which you're going to have it. Or if you require a smart contract, which is called as a programming concept, is a conditional based concept. We call them as a smart contract. It's a piece of code which will be running before the transaction is getting invoked. So therefore, there are 3-4 important components which we use in the blockchain. Okay. See, that's why I told you it is a trustless. I don't want to trust. Because blockchain will provide a trust. Blockchain will provide a distributed trust, right? Because it makes use of distributed environment. So there is no concept of a intermediate trusted intermediary. Right. Cryptographic identities will be there. Every peer will maintain their public key as well as the private keys. Right. Peer assume that any number of identities, therefore no central authority will issue the identities. That's the assumption which we are going to use in blockchain. Okay. The next one, immutable. Sir has given the brief introduction on immutability as well as consensus. Now I'm going to give what is immutable. Once it is committed, it cannot be changed. No updates, only append. Therefore, it is called as an append. Consensus means the network uses consensus in the form of some form of agreement to add the data to the blockchain. Like no one can add it. because after validating, after verifying, only that can be committed into the database, and that can be persistent into the database. So therefore, based upon the consensus mechanisms only, there's some form of agreement only, we can mute, and the consensus mechanism will work in such a beautiful manner. As already a lot of consensus mechanism algorithms are available in the market. Okay. And the smart contract, I told you, the smart contract is a piece of logic, business logic code, depending upon the application. Who are creating this blockchain, they'll create some rules and they will embed it, right? It will be executed along with every transaction. That's a very important. It will execute it is embedded into the blockchain. It is signed and verifiable, because it will verify the signature and it will verify the signed signature and verifiable. And it's a piece of code, programming language, which we are going to write as a computer code. It's like a conditional statement. So therefore, contractual conditions that will be incorporated in the form of a policy. That's why we call them as the third one is the smart contract. So therefore, you see, we can reduce the cost, trusted shared transaction, reduce of errors. We can use it very easily. Replication we are going to apply, and I'm concentrating on cryptography. That next coming we will try to see cryptography, and auditability can be easily done with the value of blockchain. The next one is how to find and transfer a blockchain. Now I'll give 1 or 2 minutes for any doubts before I go to this topic. Any doubts is there for this one?
No doubt, sir.
Sir, can you
Now,
please
one question I have received that 59 is the redundancy is more. In what context the redundancy is more, sir? In what context you are saying that redundancy is more?
Sir, one question.
Number 59. Number 59, you told redundancy is more.
Sir, I am Ramesh, sir. It's my doubt, sir, because every block is linked to the previous block. No, that's why maybe I'm thinking.
Right, sir. I'll give an answer to you. Suppose, for example, at time is equal to T0 instances, you have created a blockchain. First block is already committed into the database. All the members have a block 0 now. Now, at a time, maybe at 1 hour time, you have created block 1. Now, block 1 is not block 0 is already persistent. Block 1 you are adding to that. There is no replicated. You are not replicating block 0 once again. Block 0 is already committed. Block 1 you are adding, isn't it? There is no duplicate of that. Replications is there.
Okay. Sir.
Hello.
Hello, sir.
Yes.
Is there any limitation in number of transactions for the block?
No, that depends upon your type of application you are using. If you are using permissioned or public private blockchain, then number of transactions depend upon the application. Suppose 10 transactions or 4 transactions or 6 transactions. If you are using public blockchain like Ethereum, right? There is no restriction. You can create number of transactions in a block.
Okay. Thank you, sir. Thank you.
All right. Supriya, madam, she has asked the question difference between Hyperledger and Ethereum. Ethereum is a public blockchain, and Hyperledger is a permission private blockchain. Both are different.
Sir, excuse me, sir.
Yes.
Sir, any simulation tool is available in the blockchain technology, sir?
Simulation tool you can implement. Suppose, for example, on what context you want to, application oriented you want to apply, or a research oriented you want to apply.
Research oriented I have to apply, sir.
Pardon?
Research oriented, sir.
Yeah. Suppose, for example, now if you are applying for cloud computing, isn't it? For cloud computing, you can use cloud sim. If you are using for computing, you can use fog sim using blockchain. If you are using for IoT, you can use NS3, or you can use this Mininet. If you are using for application, you can use Hyperledger Fabric, or if you are using a public blockchain, you can use Ethereum. So depending upon your application project research wise, you can use it. For what type of application you want to apply blockchain, that is depends upon, then respectively you need to apply. Okay.
Regarding a wireless sensor network, sir,
See, wireless, that's a question now. It's a big $1 million question. Wireless sensor nodes are very tiny nodes, in energy constrained nodes. What is the need of applying blockchain there? That's a question. Now, I'll give an example now. Suppose, for example, we have a wireless sensor networks. Wireless sensor means various sensors will be placed and all the information will be sent to the sink. Yes or no?
Yes, sir.
Right. Now, we have a different wireless sensor network 1, 2, 3, 4, 5. And all the sinks will be there. Now, you can create a blockchain for all the sinks, not for the sensor nodes. Now, sinks will collect the information from their sensors, and from there you can provide the security.
Okay, sir.
There you can apply blockchain.
Okay, sir. Thank you.
Right. For healthcare, which simulation is there? You can go for Ethereum or you can go for Hyperledger Fabric, madam. Or sir, I don't know what is that ID number 63. You can use healthcare. You can use Ethereum, which is there. Where control will not be there, but Hyperledger you can have your own control.
I want to automate the electrolysis system. So can I use blockchain in that day?
Madam, go ahead, please. Be audible.
Sir, excuse me, sir.
Yes.
I want to. Can I implement voting system, online voting system?
Yes, absolutely. There is. You can. You can implement, madam. That's not a problem. Use Hyperledger Fabric. You can implement.
Okay.
Sir.
Yes.
What is the difference between Ethereum and Bitcoin, sir?
Bitcoin is a different. See, Ethereum is again a blockchain technology. ETH, we call them as ETH. ETH. It's also blockchain technology. Bitcoin is also blockchain technology. Both are using blockchain technologies, but that is a permissioned one, and this is a public one.
Which one permission, sir?
Bitcoin.
Sir? Okay, sir.
Bitcoin. We can implement Ethereum using Bitcoin also. Yes.
Okay, sir.
Right. Now, shall I proceed? Now, here you just see that how to find a new block. Now, we have a transaction 1, we have a transaction 2, we have a transaction 3, we have a transaction 4, and we have a transaction 5. Different persons have created different transactions, right? Different transactions. Now all the transactions, whatever we are going to do is these transactions will be formed as a block. Right, these transactions will form a block, right? And this block will be validated by a node, right? We have given special permission to certain P's or certain nodes who will validate the block. If the block is validated and it is correct, and it is correct block, then it will enter into the blockchain. Therefore, it's called as a blockchain. And see, if we see here, these are all already stored in your database, and a new block is created. Only everyone will update their block. Everyone will update the block. So therefore, this is a way of finding a new block and creating a new block, and it is stored to the existing chain, right? Now you see, verify all the transaction, stuff the transaction into the block, give the mathematical puzzle to the block, and add the block to the chain. That's the concept of right. There is a special miner is there who is going to do all this responsibility. Now, here some cryptographic primitives will be used. How to transfer a block means we are going to use the concept of digital signature. I'll give a clarity about digital signature. How many people already taught this course called network security? Can you post the answer? I have type the how many people already taught this course to the students network security or crypto?
Sir, I had taught already this.
Yeah, yes. I too taught this subject, sir.
Whoever taught it, sir.
I'm also taught it, sir.
Now, whoever not taught, you please know. Whoever taught, please be calm. Whoever not taught, you please tell no, so that I'll come to know that a majority of the people. So majority of people they are saying no. Oh. Yeah, majority of the people doesn't. I think you have studied in your graduate level. Graduate level while studying your BTech degree or MTech degree, you have studied this course. I think you have some idea regarding that. But technically, if you want to implement, you should know some basic concepts of to understand in detail about blockchain. You need to apply. Right. Anyway, I'll try to give the briefly about this these concepts to all the people. Right. Now, digital signature is one of the important application which is widely adopted application in cybersecurity, which we are applying here. Now, only you can sign. The person who is going to send the transaction, that he is going to sign, he is going to create a signature. Right. The other person who can verify my transaction, he should verify. He can verify my transaction. So, therefore, to apply these cryptographic primitives, we are going to use the concept of public key cryptography. Public key cryptography, I'll tell you the public key cryptography time is permissible. Today only I'll cover, otherwise tomorrow morning I'll cover. Right. I request the people, please try to install Ubuntu if possible, so that you can do hands on there itself, and you will feel a lot of, otherwise it will be boring listening 2-3 hours. Few people will go away and a few people will listen. If you practice it, it will create a lot of interest among you. And you cannot deny. Non-reputation will be there, you cannot deny. Once you upgrade the crypto system, you cannot deny. So you can cite, you can verify, other people can verify your transaction, but you cannot deny. So this is a way of how to transfer the block from one person to other person. Okay. Right. Now, this is a very important one, blockchain internal architecture, which we're going to have it, a blockchain internal architecture. Now, a lot of people will get a clarity how to create this blockchain internal architecture, which we're going to create it here. Right. Now, let us see this blockchain architecture. We already seen this slide that hash of referring to block 1. Block 1 is referring to the block 2. Block 0 is block 2 is referring to the block n. We are going to have it on this concept. If you see, the futures are there. It's a linked chain of transactions that can be replicated globally to billions of nodes, and each and every transaction will perform using the hash pointer. Now, if you see this, this is one transaction, this is another transaction, this is another transaction. Now, you see, now I'm going to create a signature of owners one signature with my private key. I'm going to create the signature with my private key. That signature will be verified with the public key. Right. Now, every public key will be created a hash. Every public key, we are going to create a hash, and we are going to create this signature. If public key have been changed, its hash value is also changed. So therefore, this is the transaction 1, which is linked to the transaction 2. Transaction 2 is linked to the transaction 3. Everything, this is called as one block. This is called as a one block. If you see block 2, if you see the transaction 3 will have the owner's 2 signature. Owner's 2 signature will be signed by using the private key of the owner 2, and can be verified with the owner 1 public key, and hash is there with the owner's 1. That will be created, the hash will be linked with this value, which is for verification, for further verification. Right. Now, this is very, very, very important internal architecture of the blockchain. Now, this is a very, very, very important one, which is a very, very important one. Now, if you have seen this here, this is the block which you're going to have it. These are the list of transactions. This is some state, database state we can have. This is some database state we can have. There is a target difficult value. Suppose, for example, now what I'm saying, from morning to now up to 4:45 or 4:55, few participants, they have not attended, but one person has attended at 4:55. Assume 4:55, one person has attended who has been registered. He has not attended from last 4 hours, but he has attended last 5 minutes before. Now, there is a single, there is a problem. All the participants will give objection. No. From morning we are sitting and we are listening. How can we allow the other person at before 5 minutes? Then we have given a challenge to that fellow. Okay, man, we'll allow you you give a seminar or assignment from the morning 4 hours, whatever it has been discussed, that's a difficult target value you have given to that fellow. If you complete it, then only we'll allow into the network, otherwise we'll not allow into the network. That is a different target value which is going to have it. Here, how we can achieve the target value is the hash value should start with 4 zeros. That I'll tell you in the next slide. All right, this is a difficult target value, and we have a Merkle tree that I am going to discuss in detail about this one, Merkle tree. Right, this is a block n+1, n+2, and n, which is going to create a block chain. Okay. Now you see, now we are talking about Merkle tree. If you see the blockchain here in the previous slide, which I discussed here, sorry, yeah, this one. Now this is a Merkle tree which we are going to discuss about. First we'll try to discuss about Merkle tree. We'll discuss about nonce. We'll discuss about the target difficult value. Okay. Next, let us go to this slide here. We are going to see. Now, if you see this diagram, if you see this diagram, which is a very interesting one, we call them as a hash tree or Merkle tree. This is a transaction. This is a hash of the transaction. This is another transaction. This is a hash of the transaction. This is a transaction. This is a hash of transaction. This is a one transaction. This is a hash of transaction. The hash of these two will be stored here. The hash of these two will be stored here. The hash of these two will be stored here. And this hash is referring to the previous hash. Like this is called as a hash chain of blocks. Now morning, I think one person asked that it's a hash value. It's a hash value is nothing but a hash value of all transactions. Right? Now we'll try to see in detail with an example of that. If you see this transaction now, right? Data 1 hash value is this one. Data 2 hash value is this one. Right? Data 3 hash value is this one. Data 4 hash value is this one. Right? These two hash values is this one. These two hash values is this one. These two hash values is this one. And this one is called as a transaction root or Merkle root. Or Merkle root. Right? And it's referring to the next the new block which we can have. Okay. Now this is a Merkle tree. A Merkle tree is a hash tree that efficiently summarizes and verifies the large integrity of data set. We can easily store in the form of Merkle tree. Right? Hash of transactions are stored in a form of a tree. Therefore, it's called as a hash tree or binary tree. Right? And we are concatenating the child nodes, child hash values or parent hash values to get the Merkle tree format, which we can have. So we know that if a binary tree whose time complexity is order of log n for finding the transaction among n. Okay. Now, right now we are going to see an example of how to build a blockchain. Before we implement anything, first of all, we should know how the blockchain can be built. Okay. Right. Now, how it works is
one question,
like this. Yeah, please go ahead.
Sir, one question, sir. Sir,
please go ahead.
Hash function will be same for all hashing, sir. Sir, hash function will
absolutely.
be same for all hashing, sir.
Yes. Hash. Suppose current blockchain they are using hash 256, SHA-256.
Yes, sir.
Okay.
So for all.
Hello. Yes. Excuse me, sir. I have a one single question related to these questions. So associated to the hash function that we are basically using, right, sir? So as actually, I myself is specialized in the cryptography sites. So whatever the papers that I have gone through, that the energy consumption, particularly the hash functions, hash algorithms, is very high. And suppose if this chain is very large and Merkle tree is very large, the energy consumption will be very much more. So it is a very great
application, sir. That depends upon your application. Suppose, for example, I'll give an example to you. Suppose, for example, now I want to create a digital certificate, digital academic certificate.
Okay.
We'll try to have off-chain and on-chain, right?
Okay.
Off-chain hash values will store in the database, and whose link will be staying in the, like you come across this concept of B trees, B plus trees.
Yes, sir.
We can implement the same concept here also. If we are storing all the hash values, we'll store all these things in the database, right?
Okay.
And whose link will be stored in the blockchain. Finally, only one hash value will be stored in the blockchain. That is called as the on-chain. Off-chain, all the hash values will be stored in the off-chain. It's like a B tree or B plus tree for faster indexing.
So in this method of the off-chain and the on-chain, the energy consumption will be reduced subsequently. Okay, fine, sir. Okay,
that
thank
depends
you,
upon
sir.
your mechanism which you are using, sir. Okay.
Okay, sure, sir. Okay.
Hello, sir.
Yes.
What about the mathematical puzzle?
Sir, 1 minute. I'll complete this slide. This is the last slide, right? Then
Okay.
we'll have a question answer. Okay.
Okay, fine, sir. Fine, sir.
Last slide. Okay.
Fine, sir.
Right. Don't mind. First, we'll try to complete this one, and then I'll come to question answers. Now, first, the thing is the transaction will be initiated. First one is transaction will be initiated, and the same transaction will be broadcasted to all the peer-to-peer network, right? That's a very important one, peer-to-peer network, which we can have it. And the network is cryptographically validated. That we'll see tomorrow how it is going to validate the transactions cryptographically. That's the next step, which we could have it. Cryptographically validates, right? Which we're going to have it. And the transaction is combined into the block with other transactions. That's another one. And the blockchain is added to the chain, right? The new block is added to the chain. And finally, which we are going to get it is what the transaction is complete and the record is permitted and immutable. So this is the process of a blockchain, how it is going to work, right? This is a process which we are going to complete in the blockchain. Theoretically, we can easily say this can be done very easily, right? That's it for this session. Now I request if you have any queries so that we can have the question answers.
Sir,
one question. Good evening, sir.
Hello.
Yes.
Sir, actually, before 4 or 5 slides, you are talking about norms and mathematical puzzles.
Yeah,
has to be solved by the miner. That will be solved by the miners. That will be taught by tomorrow, sir?
Tomorrow.
Okay. Thank you.
Tomorrow I'm discussing about norms, hash values, how it will be there, everything that I'm going to discuss tomorrow. That depends upon the peers, peer of a network. Who are the peers who is going to have it miners? That we'll discuss.
Sir, one question, sir. Sir, one question, sir.
Yes, go ahead.
Sir, who will validate the transaction, sir? Is there any separate person or among all the only who are involved in the
application who is going to create a blockchain? There will be some peers who are the validators, isn't it? Now for your application, now suppose for example your principals are nothing but your validators. For our application, our principals will be the validators. Who will be the validator? Means Atal chairman will be the validator, Atal chairman director will be the validator, coordinator will be the validator. On top of that, it's a distributed hierarchy.
Okay. That means who has created
the application which you are using.
That means who has created the blockchain? Those persons only validate the transaction.
Yes.
Sir.
Yes, madam.
What is miner, sir?
See, the miner, see here, it's a node, it's a piece of node who is going to perform the transaction, who is going to validate the transaction, verify the transaction. See, there are different roles of nodes are there, madam. Tomorrow I'll tell you what is that miner. Not every node will be a miner. See,
so each and every node is called.
Now, I'll give example to you. Now, if you take a role of a principal, his role is different. If you take a role of the HOD, his role is different. If you take a role of the faculty, his role is different. Yes or no? You got my point?
Yes, sir. Yes, sir.
See, minor, the load of the principal is totally different. His role is different. He will mind the things. He will keep whole institute in touch. All these things. His difficulty is different. So we are assigning a different role. Who we call them as a minor, who will validate the things, who will verify the things, who will make the immutable or not. After that, it is committed or not. Every person will have some responsibility in a blockchain network. That we'll discuss tomorrow. Okay.
Okay, sir. Okay, sir.
Sir?
Sir, good evening, sir. Sir, good evening, sir.
Yes.
Sir,
Yes.
good evening, sir.
Good evening. Good evening. Please.
Sir, actually, morning sir said minority concept. Minor concept.
Hello.
Sir, whenever you, sir. Hello,
See, I'm
audible,
not getting
sir?
your voice. Hello.
Sir, hello. Hello.
Hello. Your voice is not audible.
Sir, now, sir, it is audible.
Yes.
Sir, in morning section, sir said minority. Sir, in that minority concept, we have to use the only one hash value. But now we are telling that the hash value is different. Hello.
One hash value. See, if you
Sir,
create
whenever
10 transactions, 10 hash values will be there. 10 hash values will be merged and then it will create a hash tree, Merkle tree. You're talking about Merkle tree, no? Merkle tree is only one hash tree, hash value.
Okay, sir. So for that only I'm asking. So whether we have to using only one hash value or we have to use a multiple hash value.
No, one hash is nothing but multiple transactions. We are going to, every transaction will have a hash, isn't it? If any modification is going to happen at the transaction level itself, that is violated blockchain. No transaction need to be changed. So every transaction will have a hash, and it form a tree. And hash root, the root of a binary tree is called as a hash tree. That hash value will be stored in the blockchain.
But sir, in morning sir will be showing. They added the more
Given one
transaction.
example for that. Yes, given one example, if we have created multiple transactions in a block, multiple hash values will be there and it will form a merge.
Okay, sir.
Okay.
Sir, that is my doubt. Okay, sir.
Oh.
Sir, and then one more thing, decentralized. Sir, in the decentralized, so for all the person having all the details, all the node having all the details. So if you take, there is one disadvantage is another. It will be take the more memory consumations.
See, every technology there are some drawbacks will be there. That is see, we need to do a lot of research work to overcome those challenges. If blockchain has certain drawbacks.
Okay, sir. Okay, sir.
So therefore.
Okay, thank you, sir.
Yes.
Hello, sir.
Hello.
Hello, sir. Good evening.
Good evening, madam. Please.
Sir, could you suggest some basic books to learn regarding blockchain technology, sir?
Suggestion means you require some textbooks for that?
Yes, sir. For
there is a mastering in blockchain textbook is there.
Okay, sir.
Mastering in blockchain and hands-on blockchain and hyperledger. One more textbook is there. You can go through those textbooks.
Thank you, sir. Tomorrow morning we have to need Ubuntu for any hands-on session,
It's
sir.
recommendable, madam. It's if we are having, it will be good so that tomorrow we'll try to see some cryptographic primitives. How can we implement which is useful for blockchain, so that it is easily understandable for you. We can understand very easily blockchain.
Okay, fine, sir. Thank you, sir. Sessions
Sir,
were
is
very
it?
nice. Thank you.
Yeah, session was excellent, sir. Sir, one question, sir, I'm having.
Ma'am, sir, please.
For tomorrow session, is it Ubuntu virtual machine you said, sir? We didn't get, sir. Both are different.
Virtual machine, see, people who are having dual operating system doesn't matter. People who doesn't have Ubuntu, you create you try to install VMware and then you try to install Ubuntu on top of that VMware. Virtual machine, you can create a virtual machine and you can install Ubuntu on that.
Okay, sir. Okay.
Easy for you and easy for you and.
Yes, sir. Yes, sir. We'll do that, sir, for tomorrow's session. Interesting, sir.
So
Interesting.
that will be interactive. Tomorrow it will be interactive, more interactive rather than now
Okay.
I'm giving a lot of information. Tomorrow you can give your answers also.
Okay, sir. Okay. Thank you, sir.
Thank you. Thank you.
Hello, sir.
అడుగు
Hello, sir.
వాళ్ళ క్వశ్చన్ ఎట్లా అడుగుతున్నారు మ్యూట్ చేయండి నన్ను మ్యూట్ చేసి చెప్పు ఫస్ట్
Hello, sir. Hello, sir.
Sir, we will continue tomorrow morning. We will share the time on WhatsApp group. Hello.
Hello. Today question is there, sir.
Yeah, today the session closed. So tomorrow morning, maybe 9:30, we will discuss on group WhatsApp group, sir.
Okay, sir. Today any quiz is there, sir? Any quiz?
Quiz? No, sir. No. On the last day, we will conduct quiz exam.
So
Okay,
quiz
sir, thank you.
exam through Google Form or
Sir, I'm not getting.
quiz exam conducted how, sir?
Exam?
Yeah.
Yeah, regarding exam, everything we will discuss in WhatsApp group, sir.
Sir, is it possible to share the PPT today?
Yes, sir, we will do it through WhatsApp only. We'll take from sir and we will share it.
Thank you, sir. Thank you.
Okay, sir. Thank you. Thank you, Vannadal.
Thank you very much, sir.
Thank you.
Thank you, sir.